Hello, so we're going to keep going for our last lesson in 2.7. Now this one is going to be really similar to some of the things we've seen before, so if you feel confident about using tables and graphs for tangent lines and secant lines, feel free to skip the notes on this one and go straight ahead into working for your 30 minutes on your homework. If you want to do the review, get yourself all ready and we're going to get started. So here we have a table, and I've also made the graph for this function where we have numbers of stores in over time. So here in number 1, A through C, we're asked to find the average rate of growth. Now remember, average rate of growth is the same as the slope of the secant line, f of b minus f of a over b minus a. So you can use the values from the table. Here we are going from 1996 to 1998. So those are our a and b values. And we grab our other values from the table. So in 1998, there were 1,886 stores versus in 96, there were just 1,015. And you can calculate that out as 435.5. Now you can see here it asks to include units. Now the nice thing, we've talked about this before, with the units we can look at what it's calculating for these numbers. So in the numerator we are using stores. In the denominator, we have years coming from our table over here. So this then would have the unit as stores over years or stores per year. And that is the average rate of growth over those 2 years. There are 435.5 new stores per year. Now we'll be asked similar questions for 97 to 98. So you can see that in all of these we're narrowing in around the year 1998. So in this case we're just going to trade out the second set of numbers, 4 ones from 1997. And this shows that we had an average growth rate that year of 474 stores per year. And then the last one, which is from 1998 to 99, 1999 minus 1998 in the denominator, and there were 2,135 stores in 1999, which means that year the growth dropped to just 249 stores per year. Now, these find the separate secant slopes from 96 to 98, 97 to 98, and 98 to 99. Number 2 asks, estimate the instantaneous rate of growth by taking the average of 2 rates in number 1. So I'm going to use the 2 rates that seem closest to 1998, meaning these two from 97 and 99. So remember, taking the average is the sum over the number of numbers you're adding. So in this case, 474 plus 249 divided by 2, since we're adding 2 numbers. And so then the estimate would be 361.5 stores per year. Now, lastly, it asks, estimate the instantaneous rate of growth in 1998 by measuring a slope of a tangent line. So we want to draw our tangent line in here, and we're just going to try our best. That seems about right. It's a little steep, but we're just going to look here, and if I would estimate, I would say that it's got a rise and a run of about 1 space vertically. Now you'll notice that is a third of 1,000, and 2 spaces horizontally, which is 1 year. So make sure you're paying attention to what your spaces represent versus how many like dots there are. Because here it looks like over 2, up 1. But we're really going over 1, up 333 approximately stores per year, since it's a third of 1,000. Please let me know if you have any questions about tangents and about anything that we've gone over in this lesson in the comments or schedule a Zoom. Be sure if you have any questions in the homework that you're nominating them in those forms. I'll talk to you later.